Let us continue the discussion of basic commands dealing with algebraic expressions. The next command is, if we use load linsolve or load algesis, then actually Maxima loads the package linear solver or algebraic system package. So this package allows us to obtain the solution of system of linear equations. So this is one additional package while writing the program. If we want to solve the system of linear equations, after writing kill all, we can load linear solver. By loading this, we can use this additional package which supports the finding of solution of system of linear equations. The next command is solve expression 1 or equation 1, or you can give, if it is one variable, solve the equation 1 with respect to variable 1. Solve expression 1 or equation 1, comma variable name. So this command gives you solution of the equation 1 with respect to variable 1. And remember, this command will not work if the equation contains square root function. So for except square root function, this works. In fact, the extended version of this command is solve within simple bracket. You have to write the first square bracket, which is a list containing equation 1, equation 2, equation n, and the next list, which is written within square root, contains variable 1, variable 2, etc. up to variable n. So this solve of this equation gives you solution of variable 1, variable 2, etc. up to variable n for equation 1, 2, etc. up to n. Remember, this equation will not work when the equations involve square root function. And in addition to solve, if you use the command multiplicities, then this multiplicities will give you a list. That list contains the multiplicities of each solution. That means, suppose the solution for this variable 1 is 1 time, then the multiplicity of first one is 1. If the solution of the second variable is, say, 3, then the multiplicity will be 3 times. So like that, it gives you multiplicities. Then the next command is all roots of equation 1 or expression 1. This command gives you all the roots of the polynomial or equation of one variable for the equation 1. And the next command is befall roots of equation 1 or expression 1. This command gives you big floating values of all the roots. So this gives you roots in big floating point for polynomials or equation of one variable. Then the next command is real roots of equation 1 or expression 1 up to certain bound value. Up to certain bound value, this will calculate the real roots. The next command is load to polysolver package. If you use this package, then this package allows the solve command to work for the functions involving square roots. So any polynomial which is involving square root will be solved if we use the command load to polysolver package. So this is like another package, linear solve. So load to polysolver. While writing the program, if you use this command, then if the equation involves square root, then that will be solved using solve command only. Then the next package is load Fourier underscore elimination. So this package is another package which is used to solve the equations involving inequalities, that is less than, greater than, less than or equal to, or greater than or equal to. So if the equation contains any of those inequalities, then if you want to solve them, then you have to use load Fourier elim. Otherwise, you cannot obtain the solution using the solve command. So you have to use Fourier underscore elim of expression 1 with respect to variable 1. Then this command solves any of the equation which involves inequality. So if the equation involves inequality, then you have to use load Fourier elim package, and you have to use the command Fourier underscore elim, that equation with respect to variable. So these are some important commands. Now we'll solve them. We'll learn these commands for these examples using the Maxima. And also I'd given some exercise. These exercise, by solving this, you'll understand all the commands which are related with algebraic expressions. Now we'll see the Maxima program for all of these. Alright, let us start with the Maxima commands. First one is solve the following. First one is 3x minus 9 equal to 0. So as usual, I'll start with kilol with $sign. Then I'll use the command solve. What was your equation? 3 into x minus 9. I'll not give you the variable 3x minus 9 equal to 0. Right? Simply I'll give this much. And let us see what happens. So you got a solution. Solution for x. Even though I have not specified the variable, because it is a one variable, it has taken x. Or you can write this one like this also. Solve 3 into x minus 9 equal to 0 for variable x. Shift enter. You will get the same solution. Solution will not be different because the same variable is specified. And the next one is 2x minus 4. So write by the same way. Solve 2 into x minus 4 equal to 0. You can give the variable. Yes. The solution is x equal to 2. In the case of single variable, you don't have to specify the variable name. Straight away you can write solve that equation. The next one is solution for quadratic equation. Solve x square. X square means x cap 2 minus 8 into x plus 4 equal to 0 for the variable x. So this will have two solutions. Let us see. Yes, the first one is x equal to 4 minus 2 root 3, and the second one is x equal to 2 root 3 plus 4. If you want this one in floating point, then simply you can write float of the solve. This gives you floating point solution in floating point form. Right? The next one is find the solution of x cube minus 27 equal to 0 along with the multiplicities of the roots. Okay? Solve. It's a cubic equation. X cap 3 minus 27 equal to 0 for x, and also we need multiplicities. If you use this command, this gives you multiplicities. See, there are 3 roots are there for x cube minus 27 equal to 0, 1, 2, 3, and they are repeated only once. Therefore, the multiplicity of first root is 1 time, multiplicity of second root is also 1 time, and multiplicity of third root is also 1 time. Okay, and the next one is, as usual, we'll write solve x square minus 2x minus 2 into x plus 1 equal to 0 along with multiplicities. Let us see. See, x square minus 2x plus 1 equal to 0 is having 2 roots and both the roots are 1. So therefore, the multiplicity of this root is 2 because it is repeating twice. So this is how you can find the solution along with the multiplicities of the roots. Next command is all roots and befall roots and real roots. Using these commands, we have to find the solution of the following. Okay, as usual, I'll start with kill all. Right. Next, the first equation, instead of straight away writing the equation in the solve command, I can assign that one to something and I can call that, say for example, f is x square minus 8 into x plus 4 equal to 0. This is my equation and I want to find the roots of all roots of this equation. So what is the command? All roots of equation. All roots of, what was your equation? F. So straight away you can obtain all roots. See, this is a quadratic equation. So it has 2 roots. I've stored this quadratic equation in F and all roots of that F. Otherwise, you can write this equation in this itself. See, all roots of this equation. You'll get the same answer, right? Next, we want to find big float of this. So befall roots of this expression f. This gives you, this gives you all roots of this expression in big float. Remember, b to the power of minus 1 means 10 to the power of minus 1. b to the power of 0 means 10 to the power of 0. And we want to find the real roots. You know the command for real roots. Real roots of f. Remember, you have to give a bound for this. So let me give bound as 1. So it will give you all the solution within 1. See, 3 by 4 and 29 by 4. They are one and the same as this. Right? So this is how you can use the command all roots, befall roots and real roots depending on the situation for finding the solution. Let's see another example. The next example is, what was your next equation? It is x to the power of 4. Okay, x to the power of 4 minus 2x square. So 2 multiplied by x cap 2 plus 2x, 2 into x. Right? Now let me give the bound for this as some, say 2. Okay, okay. Let me give this one. See, your equation was x to the power of 4 minus 2x square plus 2x equal to 0. Fine. And since it's a biquadratic equation, it has 4 solutions. So there are 4 roots are there. So one is 0, another one is this, which is a complex value, and this is another complex number, and one rational root. So it has 4 roots. Now these roots are expressed in big float. And here real roots, all the real roots of this biquadratic equation within the range 2 is given. Remember, it is giving you only real roots. So these 2 roots are given. Complex roots are not given here because it gives you only real roots. Suppose if I give real roots within the range 1, see what happens. Yeah, it gives you root which is there within range 1. These 2 roots are within boundary 1. Suppose if I give 3, this finds the roots which are in the range within 3. Depending on your choice, you can give this. Okay. Now, the next example is ax square plus bx plus c equal to 0. Okay. So, a into x square plus b into x plus c equal to 0. Let's find out. See, it is saying expected a polynomial in one variable, but found variables a, b, c, x. It is saying these are variables. These are not constants. So it will give you, this command gives you only solution for polynomials in one variable. Right? So you should remember that it gives you solution for only polynomials in one variable. Right? Is that clear? Okay. Now let's move on to next. What is your next example? Yeah, solve the following simultaneous equation. So we have to find the solution of simultaneous equation. Right? Okay. Kill all. It kills all the earlier stored values. As I told you, we can use linear solve package, linsolve package. Linsolve package is used, right, to solve the system of linear equations. Now let us solve this one. As usual, I'll use the command solve. But remember, there are 2 equations are there. So I have to use square bracket. The first square bracket is indicating list of equations. And the second square bracket indicates the list of variables. So in first square bracket, what was your equation? 5 into x minus 9 equal to 0. That is one equation, comma. And the second one is 5 into y plus 1 equal to 0. So there are 2 equations are there. How many variables? 2 variables are there, x and y. Now let us see what it gives you. See, you got the solution for, common solution for system of equations. X equal to 9 by 5 and y equal to minus 1 by 5 by solving these 2 equations. So this package allows us to find the solution of system of linear equations. Alright. Now let us solve another example. Kill all. What was your next problem? Yeah, I'll use solve. There is only one equation, right? X cap 2 plus y cap 2 equal to 3 for x. See, you got the solution of this equation for x. I didn't use the y, right? Suppose if I write solve this equation for y, then see what happens. This gives you a solution in terms of y. See, this gives you a solution for y. Next, kill all. Next equation is, right, solve. Now I'll not load the package because already I've loaded the lint solver package. Solve. Every time you don't need to load the package, right? X square. So there are two equations are there. So I'll write within square bracket x cap 2 plus y equal to 4, first equation, and the second one is 2 into x minus 3 into y equal to minus 4. And there are two variables are there, x and y. We want to find the solution of common solution of this. See, there are two solutions are there for this. One is x equal to 4 by 3 and y equal to 20 by 9, and the other solution is x equal to minus 2 and y equal to 0. So this is how you can obtain the solution, right? Even if there are three equations are there, right? Let me solve that also. Kill all, solve. First square bracket should contain only equations. Next one should contain variables. X plus y minus 2 into z equal to 5. And the second equation is x minus 2 into y plus z equal to minus 2, and the third equation is minus 2 into x plus y plus z equal to 4, and there are three variables are there, x, y, z. We want to find the common solution. Let us see. So this has no common solution, right? The solution does not exist. That's why this one is showing you empty. So next command is use of polysolver package. All right. So let's see that. Kill all. Yeah, you have to first load to solve in the poly underscore solver package. Then you are trying to poly solve. Then you have to write the equation. What was your equation? 4 into x equal to square root of x cap 3 plus 3 for x. Oh, this has come here, so it should come outside of this. Okay, now execute this. It takes some time, but output will be displayed. So percentage of union 4x equal to square of this. Yeah, 4 into x equal to square root of x square, x square plus 3. So this is square plus 3 for variable x. So here it should be given within square bracket. Yes, this is how you can get the solution, right? This is the package which allows you to find the solution of a system of equations involving square root. Let us see another example. Kilol load 2 poly solver and how many equations they are given? Yeah, 2 poly solve. There are two equations there, so I have to give within square bracket, right? So two equations, and how many unknowns? Two unknowns. What are they? The first one is y is equal to 2 into x, and the another equation is y is equal to square root of x square plus 3, right? And the variables are x and y. Let us see whether we can get the solution or not. Yes, we got the solution of these two equations. So this is how you can solve using the two poly solver package. Otherwise, for solving the equations involving the inequalities, this will not work. We have to use another package. What is that? Kilol load Fourier elim package. Fourier elim package, then Fourier underscore elim of, what was your equation? It is x square minus 4 greater than 0. X square minus 4 greater than 0, right? We have to find the solution of this. So let's put a square bracket for the equation. Then variable is x. See, this is the solution for this system of, this equation. So use of this package, remember, if you don't use this, then in the solve command this will not work. So you have to use this equation with this package. So load Fourier, next example is load Fourier elim, and your expression is modulus of 2x minus 3, that is absolute value of 2 into x minus 3, right, minus x equal to 0. Yes, this is the solution for this equation, right? And the next example is modulus of, that is absolute value of x minus absolute value of 3 minus x, right? And this is less than 1. Right? So this is the solution for this inequality. And the next example is maximum of minus x and x is less than 7 times x plus 1. So this is the solution for, or this is the range for x. And the next one is product of x plus 1 and x minus 6, and their product is less than 0. Then we have to find the range for x. Mismatched parenthesis. Okay, here one parenthesis is missing. Okay. So this is the range for x. For these values, this equation is true. So in this way, you can obtain the solution of equations involving inequalities. So I had given some exercise, you work out, and we'll continue. Thank you.